Welcome to Study Loop.
Our question says that you buy a plastic dart gun, and being a clever physics student, you decide to do a quick calculation to find its maximum horizontal range. You shoot the gun straight up, and it takes 4 seconds for the dart to land back at the barrel. What's the maximum horizontal range of your gun? Okay, for this problem, I say that when shooting the gun vertically, half of the time of flight is spent moving upwards, right? Thus, the upwards flight will take about 2 seconds. Okay. And I'm going to choose upwards to be in the positive y direction, since at the top of the flight, the vertical velocity is 0. Okay. So I write down what we were given here. What we're given here, and that is the initial point, which we're choosing as y of 0 is equal to 0. The velocity is entirely in the y direction. Okay. T, the total time of flight, is 4 seconds, right? And at the peak, the velocity in the y direction is going to be 0, right? It's no longer accelerating upwards. It's about to start accelerating downwards, okay? And that acceleration is minus 9.8 meters per second because it's accelerating down towards the ground. And we define positive y as up, okay? So we can go ahead and then use equation 2-12 from 2-12a, excuse me, from our book, which says that the velocity v of y at a point is equal to the initial velocity vy of 0 plus the acceleration here times the time. Okay, well, we want time here, right? But our time is the time it takes for it to get to the top. So we're going to label this as t sub t for top, okay? Time sub t for the time it takes to get to the top. All right. Or I'm sorry, we don't want to solve for t sub t. We know what the time it takes is for it to get to the top. We want to solve for vy of 0. We want to solve for the initial velocity. Because if we know the initial velocity in the y direction, we can calculate the initial velocity that would be required in the x direction, because it's just going to be the velocity out of the barrel of the gun if it's shot horizontally. So t sub t times the acceleration here is the acceleration in the y direction. This is equal to minus vy of 0, right? Because v of y at the top, which is what we're considering, is equal to 0. So we can ignore that, okay? So therefore, vy of 0 is equal to minus a of y times the time it takes for it to get to the top. Okay, well, the time it takes for it to get to the top is 1/2 that of the total time, and the acceleration in the y direction is minus 9.8 meters per second. So minus a minus is plus. So this is positive 9.8, and that's meters per second squared. And that's multiplied by 4 divided by 2, which is 2 seconds. We can write this up here, actually. We'll say that t at the top is equal to 1/2 t. Okay. And if you carry this out, you find that this equals 19.6 meters per second. Okay. Now that we have that, we can use our range formula, which says that the range something is going to travel is going to be equal to the initial velocity, right, squared, times sine of 2 times the initial angle at which it's launched, divided by gravity, the gravitational acceleration. Okay, well, our initial velocity, which we just found for y, can also be applied to x, because in this case, the student shot it straight up in the air. So all the velocity was in the y direction. So the initial velocity out of the barrel of gun now is all going to be in the x direction. So this is going to be equal to 19.6 meters per second. That value squared. Okay. And then sine 2 theta. Well, if we're launching it horizontally, okay, theta naught then will be 45 degrees. So 2 times 45 is 90 degrees. So this is sine of 90 degrees divided by 9.8 meters per second squared. 9.8 meters per second squared. Okay. Now, if you carry out this calculation, you find that the range is 39 meters.